Hi, this is Mrs. Lemke, and I'm here to help you with factoring of quadratics. So if the quadratic review so far has been kind of tricky for you, I'm glad you're watching this video. That's what you should be doing. And I just want to remind you of kind of what we're looking at when we say factoring quadratics. So remember that you always would like to check first for a greatest common factor. Not doing that can just lead to having larger numbers involved in your problem than you need to, and then later on in the problem you'll probably say, oh wait, there's a common factor of 4 that I missed, and it would have been easier to do that first so that your values were smaller and easier to handle. There's also a pattern called the difference of two squares, and that has nice initials, so math teachers sometimes use those, but no patterns like the difference of two squares. If you don't know what I'm talking about, I did write the difference of two squares pattern right down here. And so if you have two things that are subtracted, that's what we mean by a difference, and they both are something to the second power. So it could be that they are something to the sixth power, because if I have something cubed and then squared, that's to the sixth, right? And this would satisfy it being a square. So it doesn't have to just be twos. Okay, just anything that would be to the second power. So if I have two things that are to the second power and they're subtracted, then you can follow that pattern in terms of factoring. Now, it really is just a shortcut. It isn't essential that you know it in the sense that you could figure it out. But a lot of us do like to have these patterns kind of sorted out in advance. You can see here that the reason this pattern works is that the parts of the distributing that I highlighted with red pen cancel each other out. And the two parts that are with blue in the distributing are what are in the pattern. Okay? And then the third bullet, and this is usually the hardest one for students, is to be able to reverse the multiplication of two binomials. So you can use guess and check, and if you have really strong number sense, that is more than fine. I know I made it all the way through high school, college, all the math with that as a technique. When I became a teacher, another teacher taught me how to do split the middle term. And I have mixed feelings about it. I think it's a very strong strategy. If you're struggling with a problem, it does take more writing and more time, so it can slow you down a little bit. However, that said, it might be a nice middle step for someone who needs to just get stronger with their factoring. Okay, so I have some examples picked out to try to address that list that was on the previous slide. So this one says to factor 4x squared minus 49. I notice that this is a quadratic, second degree. It has a subtraction sign. It has two terms. I think, oh, maybe this is the difference of two squares. Difference of two squares, okay? Because here's a difference. And I have to think if I have squares. Well, 2x quantity squared is 4x squared, and 7 squared is 49. So yes, I do. So I'm going to utilize that pattern that was on the previous slide. And each of these is 2x, and each of these is 7. Those were the things that are being squared. And then you have 1 plus and 1 minus because you don't want to pick up a third term. All right, now to check that, I easily could just do my distributing and make sure that I get this. These are the easiest questions to check. Maybe hard to do, but easy to check. All right, there are two follow-up questions. This is with the same polynomial, same quadratic. Sometimes you'll be asked to solve, and you'll have equals 0. Now you have to have equal to 0 in order for factoring to be beneficial to you in terms of solving. So now that we know that this is factored like this, then you use the zero product property to say, well, if I have a product, this is multiplication here, so I have a product. If I have a product that equals 0, the power of 0 is that you can set each one equal to 0. This would not be true if that 0 was, a 7 or a 14 or a 39 or a -5. None of these other numbers have the property that 0 does. So the 0 is really important. And we can set each of these equal to 0 and solve each part. And what those two answers tell you is actually something about the graph. So this graph would be some, curvy shape parabola, and it would have, that parabola has an intercept at 3.5. That's what 7/2 is. And at -3.5. And I know some other things about it, such as its smiley face parabola, et cetera, and I'm totally not drawing this to any sort of scale on the y-axis, okay? But I know some things about the graph because I knew some things about solving, and I knew solving because of factoring. So these are the pieces that are all going to fall together. Our focus, oh, come on, I hope Fry and Covey don't get mad at me for going off about that, but our focus really is to make sure now that you can do this kind of skill. Okay, you have to be able to do the factoring skill. All right, our next factoring question, not a difference of squares. And I can certainly tell that because it has 3 terms. Okay, difference of 2 squares, funny thing, has 2 terms to it. So this has to be something more complex than that. And so I'm going to think about this, and I'm really excited to see that this part only has an x squared. There's no other number with it. So I put this example in because usually students have an easier time with this type of problem. A lot of you remember from middle school somewhere where you learned, okay, well, I have to have 2 numbers that multiply to -96, but they add up to 4. That's exactly what you want to think with only if this beginning part doesn't have a leading coefficient, okay, if it doesn't have another number up here. Otherwise, that kind of thinking is not sufficient, okay? So we are going to be all set to do this. Okay, so we want to get -96. The way to end up with a negative is to have a negative times a positive. The way to get that highlighted x squared is an x times an x, so that's all very clear. And then I just have to think about different ways to break up the 96. So that's the part where like having stronger arithmetic helps you, but if that's not a strength of yours, you just have to keep working on it. So I've got a 12 here and an 8 here because 12 times 8 is one of the options for 96, and it is the option where I have numbers that are 4 apart. So here I get -8. Here I'd get 12, excuse me, I shouldn't have said -8, -8x. Here I'd get 12x, and when I add those together, I get 4x. Now, let's try this again, but let's use the split the middle term strategy. With split the middle term, I should say you couldn't have figured out, that part. If you're watching this video, it's probably because you feel you need it. So take that 1 at the beginning and take the -96 at the back and write -96 off to the side. Okay, a negative means I need 1 positive and 1 negative. And then I'm going to list out the ways that 96 can be created. Okay, I'm going to do that real quick, okay? You do it too. So like 1 times 96, 2 goes into that, 3 goes into that, right? Write out all the different pairs of numbers that multiply to 96. Okay, so here's the list, and I would suggest going in order because if you have this column getting bigger, this column's going to be getting smaller as you go down the list. Sorry, I don't know why I wrote a backwards arrow, but it's sort of like, you can read numbers here, and then you're like, is there anything between 8 and 9? Like, does 8 or 9 or 10 or 11 go into 96? No. And then the numbers or the factors continue this way. I guess that's what I was thinking. Okay, so we want to pick the pair that if I made one of them positive and one of them negative, would split this middle term. Or in other words, I could have something and something together that make positive 4x. And so in this case, it would be these 2 guys down here. And so what I would be doing is I'm writing the same 2 terms, and then I'm writing -8x plus 12x. And I split this 4x into 2 pieces, right? those two that I underlined in green make the middle term. So that's why it's called splitting the middle term. You're making it more complicated, but the reason that you're making it more complicated is so you can use something called factoring by grouping. Factoring by grouping is where you pretend for a brief while that you have two problems. We're going to just look at the terms that I underlined in black, and I'm going to pretend that's my whole problem. And I'm going to take out the greatest common factor, which is an x, and then there's the rest. And then I'm going to look at my purple problem here, and I'm going to think, well, what's the greatest common factor there? Well, that's 12. And then if I factored out a 12, I'd have 12 times x and 12 times negative 8. Okay, now look at all of the blue writing as one piece. Think of what goes on in your brain here really matters. Think of this red part as one piece. Think of this green, oh, that's supposed to be green, guys. I guess I didn't touch that hard enough. Think of this green part as the other piece. Within each of those two pieces, you have the common factor of x minus 8. In both the red and the green underlined pieces, you have x minus 8. So you take out x minus 8. The first piece, you have the rest of it is x, and over here, the rest of it is 12. Remember, that's how you factor out a greatest common factor. Like right over here, you factored out an x, and then the parentheses have the rest. So here, you're factoring out the x minus 8, and then the x plus 12 is the rest, like what you have left over. Now, that's exactly the factoring that we did before by my just thinking about the numbers that were involved. So I used a guess and check strategy first, and I used split the middle term second. You can see that split the middle term has a lot more writing. So if you can figure it out with guess and check, I would encourage you to do so, okay, rather than just automatically going to this. Now, given what we just did, if this was the problem that you have, you know that what you would do is set each factor equal to 0. And that would give you x equals 8 and x equals negative 12. And this result would tell me if I were looking at a graph, like if I had this polynomial or this quadratic equal to 0, these two locations are my x-intercepts. Okay, that's going to come up in this unit. I just wanted to preview that for you. Okay, so now here's a question where I can certainly understand that folks might need to do split the middle term because it is more complicated. Having that 12 in the front does make things a little bit more dicey. Okay, so I'd like you to start out, you've seen the strategy, I'd like you to start out with taking this 12 times this negative 10. That means that the special number you need to think of off to the side is negative 120. The negative means 1 plus, 1 positive, 1 negative. And I'd like you to make that list of all of the different pairs of numbers that multiply to that. Okay, pause the video and then come back, we'll compare lists. Okay, so hopefully you found all the same factors I did. Again, I encourage you to go in order. That way, when you get down to the bottom and you see 10 and 12 and you say, oh, well, it doesn't divide by 11, you know you found them all. Okay, it would be a pity to be making this list and be missing the one pair that you really need. Now, again, to determine the pair that I really need, I'm going to come over here to my question, and I know I'm going to keep the 12x squared as is. I'm going to keep the negative 10 as is. I'm splitting negative 7x into two pieces. And so I want two numbers from this list, one positive, one negative, that would make, when combined, when added together, negative 7. And so that's going to be this pair if I were to make the 15 the negative and the 8 the positive. Those two things together add up to negative 7. So I'm going to write over here positive 8x minus 15x. It actually will work no matter what order you put those two terms in, okay? Just so you're aware of that. All right, I'm going to think of my blue problem. I'm going to think of my purple problem. In my blue problem, my greatest common factor is 4x. So that leaves me with 3x plus 2 in the parentheses. And then over here in my purple problem, my greatest common factor, you might say, is a 5. Okay, here we need to think a little bit. Is it better to take out positive 5 or negative 5? Well, we want this parenthesis to match the other one. And if that's the case, I certainly need that 5 to carry the negative. Okay, I don't want the negative on the inside terms. So take out the parenthesis as if it were a greatest common factor. So if out of the first chunk, this first chunk, I take out 3x plus 2, I am left with 4x. And if in this second chunk over here, I take out 3x plus 2, I'm left with minus 5. Okay, so there's my factored form. That would tell me if I were solving an equation that was set equal to 0, I would set each factor equal to 0 to solve, and the results of those, the negative 2/3 and the positive 5/4, would be my x-intercepts on my graph. Okay, just mentioning the connection. Okay, I made up a doozy for you for the end, okay? So this is the question I want you to try. It says to factor this, okay? So I want to think about the other things that we've talked about. The first thing I mentioned was always look for a greatest common factor. Does this have a greatest common factor? Oh, it does. Okay, so you have to take out a greatest common factor. Is it a difference of 2 squares? No, it's not a difference of 2 squares because there's 3 terms, okay? So after you take out the greatest common factor, it's your choice, right? You'll have a greatest common factor out here. You'll have a trinomial, and then you can decide if you want to factor this trinomial using split the middle term, or if you want to try to do guess and check to figure out the answer to the question, okay? So I'd like you to pause. This might take you a couple minutes. That's okay. That's totally fine. But do indeed do the problem so we can see if your factoring skills are getting better. Okay, so please pause and then come back to see the solution. Okay, so my solution isn't on the screen yet, but taking out the 3 is, so hopefully you did that. Now I'm just going to show you that this one is actually not tremendously painful to guess with kind of a guess and check technique, because the 2 in the back has to be a 2 and a 1, my friends. Okay, so when you can pin something like that down, it might be easier for you to not do split the middle term. You certainly can, don't get me wrong, okay? Then the 10x squared in the front, well, it has to be 1 times 10 or 2 times 5. So you really only have a couple things to test out. And if I put a 2 here, right, if this were 2x, then this would have a common factor of 2, and then 3 wouldn't have been my thing to take out there. So that's not it. So this I'm going to try as the 5x, and here I'm going to try a 2x. Okay, and I say try because the way to test this is to look at your middle. The middle is the key. So right here I've got 10x squared, that's all good. Okay, and right here 2 times 1, got a 2, that's all good. The middle term is just where I look and see if I have a solution. So 2 times 2 times x is 4x. 5 times x times 1 is 5x. And then I look at those and see if I can get that middle term. Well, I can if both these are negative. So I'll make both of them negative. Okay? So that is the factored solution. Now you can do this with split the middle term. So I'm going to take a second and do that, and then you can come back. You can just continue watching the video, and you'll see my solution using split the middle term. Okay, I just don't want to make the video longer. So I'm going to pause for me. Okay, so started setting up split the middle term here. So notice we already took out our GCF. We're going to apply the split the middle term to that. Okay, that's the piece that we have to break down. So we are just going to take the 10 times the 2, and our special number is going to be 20. And over here I said, well, I'd have a positive 20 because positive 10 times positive 2 is positive 20. And you get a positive number either by multiplying 2 negatives or 2 positives. So I have to bear that in mind when I look at my pairs of factors here. So I want to split negative 9x using one of these pairs. So that's going to be this pair if I make both of those negative. So my split the middle term is going to look like this, 10x squared minus 5x. I'm going to put that there because it's by the 10, minus 4x plus 2. Okay, so sometimes I pick an order just to make it a little easier on my brain, but actually both orders will work. Okay, then here and here, I want to think about my GCF. So take out a 5x, because that would be the GCF from the red part. I would be left with 2x minus 1. And if I want 2x minus 1 over here, I must be taking out a negative 2. Okay, so watch your signs there. Make sure this works, double check. Yeah, I think we've got it, okay? And so then I'd have that 3 that's hanging out, my GCF from way at the beginning. This is a common factor in both this chunk and this chunk. So I'd have 2x minus 1. And then the leftovers from this first piece are the 5x, and the leftovers from this second piece are the minus 2. Look at that, same answer. So a little bit of a decision for you. Good to know both techniques. Thank you for watching this. I hope it helped you to strengthen your factoring skills.